Maybe it's in your email. It says I'm in Google, but I'm not sure totally how it works. It's me. It's just a general malaise. I don't know. I have a couple of Google accounts. I don't know how they work. Present to everyone. Okay. Let me try sending it again. No, don't mute. Okay. Copy. Google Hangout. Okay, now I'm sending it to you through Google Hangouts. So it should, okay, try that. See what happens. Noah just popped up.
I'm here.
Noah, did you have to cancel out of the other one?
No, I didn't cancel, but now I'm going to. Cause I could still hear Trevor's mom, so yeah.
Hey, Noah.
Hi.
What's up?
Nothing. I stayed up till like 1 because I was babysitting.
I stayed up to like 2. I just couldn't sleep. We watched that movie, King Arthur. Have you seen
King
that?
Arthur? Huh. I've never seen it.
It was okay. It was like a lot of magic stuff and I wish this were simple. I feel like it's designed to be simple.
Yeah. Sorry, what? Give me 1 second. I can't hear you now. I can't. What happened?
Let's see. Okay. Are you there?
Yeah. I can't hear Mrs. Peterson
Can
now.
we hear her?
Here, I'm gonna join back, okay?
Just
Oh,
did.
you can't hear?
Can you hear me?
Yeah, I can hear
Now
you.
I can.
Okay.
Okay. I can't do this all for you.
Okay.
I can't hear anybody anymore.
You can't hear me?
You can't hear us?
Can you hear me?
Can't hear me? Yes?
I can hear you.
Nod. Nod. You can hear.
You can hear me?
Yes.
Yes. Okay, maybe only one person can talk at a time? Is that right?
Hello? No, we're
I
all
haven't
talking.
muted you guys. I just can't hear you. And I could hear Noah before. Maybe this is a different setting now that there's more than one person? Okay.
No, you should be able to hear everybody.
Control room.
No, you can hear
Eject
all
any
of us, right?
bad actors.
Yeah,
I can kick you people out.
Trevor and
I'm not gonna. That's bad. Okay. So turn me up. It says there's like supposed to be some really easy way to record this. I'm broadcasting it right now. I don't know how that works.
Broadcasting would be like just live.
FaceTime
The live video
camera,
on YouTube.
default, voice. Okay. A few more apps. I don't care about that. Gosh, this was supposed to be so easy. How to record. Start a hangout. Did that.
We're still like figuring out.
Um,
No, we are in like the best.
okay,
option,
I'm
so-
just going to have to go
Yeah.
over with what's his face, the material later,
Luke. Okay.
I guess, because I don't know if this is recording it or what, and I don't want to waste any more time because it's a Saturday, right? Not if you're in agreement that you want to be doing other stuff. Yes. Trevor, can you hear me?
Mhm.
Okay, did you not nod before because this is exactly what you want to be doing today?
Just say.
Can't tell what he said. Okay, so I have my whiteboard.
All right.
Okay, are you gonna take notes?
Yeah. Cool.
I don't think so.
Ow! I just stepped on something. This is calculus. Don't worry about that. It's okay that it
got
doesn't make sense. And it's not erasing. That is. Okay. I'm just going to use notebook paper and then hold it up.
Okay.
Good?
Okay.
Can you guys still hear me? Oh, no, are you talking to your mom?
Yeah. Sorry. Yeah,
Okay.
I can hear you.
For some reason, it's not letting me hear you guys.
Okay. Well, I'm good.
Yeah, so she can hear you or not.
I want to hear you. I wish there was a way to do that.
Ask questions.
Cameraman. As guests join, hide their audio and video from my broadcast? No. New guests in my large broadcast are muted when they join? No. Then why are you muted? Cameraman. I want to hear you. Turn camera off. Oh. I mean, it's peaceful. I can't hear you. But what if you have questions? Okay.
Here, through the chat.
Oh, I got my Alexander the Great bust
Through-
yesterday. Cool, right? We can just text them through the chat. I got your messages. Okay. Yeah, so in my medieval history class, you have to be holding the Alexander the Great in order to speak. And I'm just going to, like, put it on my desk and then not give it away. Okay. So, everybody's got your math book? This is Montezuma's Revenge. I totally recognize the red, green, and yellow of the ride.
Yeah.
Okay. So, when we left off...
I'm on that ride at the same time.
Are you saying stuff?
That'd be funny. Never mind.
No. I can't believe I can't hear you. It's so weird. Never mind. Okay. So, did you guys try the homework? How was that? Thumbs up? Okay, so here we go. Symbols. I completed all of it. Okay. Can you guys see each other?
Yeah.
Okay. I started it. Oh, okay. Yeah, Trevor started it too. Okay. I understood how to do all the problems.
Most of them.
Yeah?
Most.
Yeah. Sorry, I was looking for my docs. I have docs. I don't know if you could see them earlier. They're the best docs. Okay. Let's see. I'm halfway done.
It's like 1/3 or
1314.
Like 1/3 or 1/4.
I did parts of it. Okay. So I'm pretty sure that we went through all of chapter 1 together. So you guys don't have any questions. Have you started the absolute values in your homework?
No,
No?
I've not started that. No. I did it first. I did
1/3,
let
1/4.
me see. Yeah, I did like
Okay.
1/3 of it.
Um,
Let me see.
So when it
I
comes to
did-
the absolute value, the only thing I think that you guys need to remember is how to, not necessarily how, but when to take down the sign, like the absolute value symbols themselves. I really hope that this is recording this. It says it's broadcasting it. If it's not recording it, I'm just gonna like, I don't know.
Can you hear us okay now, Ms. Peterson?
Do something out of frustration. Just like make up some sort of appropriate act for that. Okay, so when you have an absolute value, like 2x minus 5. You can't see that, can you? I'm going to try using a marker or something. I'm in my office, so I got stuff. I just need to find it. Ah. Pink. Pink's good. I like pink. Can you see it? Yeah! Okay. So the absolute value of 2x minus 5 equals, I don't know, 10. So do you guys remember how to take down, is it backwards when you see it?
No.
Good, okay. It's on my screen it's backwards. So I just want to make sure. Okay. So do you guys remember what to do when you take down the absolute value symbols? Neither of you are making much of a...
I forget.
Much movement. Okay, so I'm just going to go ahead and re-explain it. So when you have your number line, when you have your number line, so here's your 0, right? And the absolute value of 2x minus 5 indicates that it could be over here. This is 2x minus 5 away from 0. And there's the point, 2x minus 5. So on the other side, this is still 2x minus 5 away from 0, and that's all that the absolute value indicates. But it's the negative because it's on the left side of the 0. Okay. So when you take down your absolute value symbols, you have to account for both of those solutions by evaluating it for 2x minus 5 equals positive 10 and 2x minus 5 equals negative 10. So 2 answers for absolute values. When you're doing word problems involving absolute values, that would be for things like, do you guys both have your books with you? Yes? Okay. So flipping to page 55, let's do number 72. Good? Okay. So number 72. Guys, give me a thumbs up when you guys have flipped to the page. Good? Okay. Good. Okay. So it says write an absolute value and inequality for the weight range of each ball. So looking at this little table, it's got all these different sports here, and then it says the weight range of ball used. So what that's asking you to do is to write an inequality, like mathematically translate using an X where or how much these balls can weigh. But they can weigh anywhere from, like for volleyball, 260 to 280 grams. So you know that there's a range. And when it's a range of values that will work and are acceptable, we're going to use an inequality for that. And can you still hear me, Noah? Okay, yeah. I just saw you took them off. Okay, yeah. So we're going to use an inequality for that because remember, if we're using an equal sign with an equation, there's only one solution. And that's clearly there are more than one weights that are acceptable. So for volleyball, it says anywhere in between 260 and 280 is A-okay. Cool. So to do the volleyball and represent this as an inequality, what we need to do is figure out what's in the middle. Because if it's in the middle, then we can figure out how far to the right or the left this weight can range and it's still okay. Does that make sense? Trevor, does that make sense to you?
Mm-hmm.
Yeah, okay. So how many spaces are in between 260 and 280? Well, just subtracting them, there's 20. Yeah, get your sign language, Noah. So there's 20. So that means that halfway in between is 10. 10 on each side. So this point right here, the weight can range plus or minus 10, and it's still acceptable. It's within the acceptable range. So what point is 10 from 260 and 10 from 280 backwards? 270. Does this make sense? Okay. 270. So it's really weird right now that I can only hear myself. It's like I'm talking to myself in this room. It's weird. Okay. So 270 minus x, because x is going to be the weight that it actually is. And if we're finding the difference in between the middle, the ideal weight, and the weight that the volleyball actually is, then that's a difference. That's the fraction. Does that make sense? That's how you translate the situation into the math speak. And we need it to be, so, explaining how I know that it's going to look like this. 270 is the weight in between. Did you guys just hear a really loud beep? Okay, so Trinity just woke up and her mom is texting me. 3 times, so another one should be coming. There it is. Okay. Did I record it? I don't even know how to answer that question. Okay. Oh! Fun fact. The college I went to right now, their football team is playing right now. I'm a huge football fan, right?
What college?
They're playing Ohio State, who is like number 3 in the country, maybe number 2. I don't remember. My team has not been ranked from my college in like 30 years. Hey, Anna Bug. Anna. Hi. Hi, honey. It's my dog. I have 2. They're like identical. They're the best. They're Dobermen. Because each one's a Doberman. So when it's plural, they're Dobermen. Yeah. This is Anna. She's named after the biblical prophetess that announced that Jesus is the Messiah as a baby in the temple of Jerusalem. So, Ohio State is screaming UNLV right now. In the first like 5 minutes, it was 14-0, and then UNLV knocked the ball out of their hand right near the goal line, and instead of scoring, Ohio State got a safety. Okay, so this is just a great day for me so far. Anna. Okay, so going back to this, how I translated this into math speak. So we figured out, there she is, that by plotting the range on the number line of 260 to 280, we figured out the middle. So we could mathematically represent how far away from this point with just using one point instead of saying like 260 and 280. But, did you sneeze? Bless you. Okay. So we figured out how to mathematically express that, like quantifyingly, it's not a word, quantifiably, how far away from this point, 270, the weights can be and still be within, like that's why we needed the center point, within 10 of the center point. Because it can't be within 20 of 280 because it can't be 300. So we needed to find a point that was in the middle of the acceptable range and define our range using that point. Does that make sense? Good. Okay. So we know it was going to be within plus or minus 10 because it can be 10 away in either direction. So what we do, if we're thinking about what plus or minus 10 means, well, that's the exact same thing as the absolute value of 10, isn't it? Because the absolute value of 10 is just indicating 10 spaces. Did something happen to Trevor's phone call? It's just his picture now, not his video. Trevor, if you can still hear me. Oh, there you are. Okay, you popped back. Okay. So the absolute value of 10 says just 10 spaces away on the number line. It doesn't say in which direction it is. So it could be plus or minus. So instead of writing plus or minus, if we want to actually write this in one single statement mathematically, we can use the absolute value instead. Make sense? Cool. Mm-hmm. So the absolute value we're going to put over here, because the absolute value of 10 is just the absolute value of 10. What we're actually finding is the difference in between the middle weight that's acceptable and the actual weight that that ball happens to be. And the difference needs to be 10 or less. Does that make sense? If the difference is 11, that means it's either going to be 259 or 281, and that's outside of the acceptable range. So it needs to be 10 or less to be within 10. So I'm going to do the absolute value to indicate that it could be 10 this way or 10 that way, and then it has to be less than or equal to 10. And then when you solve it to take down the absolute value signs, you're going to do 270 minus x is less than or equal to 10. And then you're also going to do negative 270 minus x is less than or equal to 10. Remembering that when you solve, when you take this down, or like actually solve this for this negative, anytime that you have to multiply or divide across an inequality sign with a negative, you have to flip the sign. Does that make sense? Good so far? Okay. So that's how to do it for number 72. Okay, so why don't you guys really quickly, especially since I can't hear you. Oh, what college did I go to? Oh, I just saw your message, Noah. I went to UNLV. UNLV. Go Rebels! Yeah, I wasn't thrilled about it, but it's what God wanted for me, and so yay! Okay, so what I want you guys to do is kind of flip through your books in chapter 1 and see if there's anything that you can see. You have a question.
Can I have your phone? Yeah. On.
I can't see that. It's your face is this big, so I can't see the message. Yeah. Trinity's trying to get on. Okay. I will invite Trinity. I don't think I'm going to be able to hear her because that's just delightful. But TrinityAnda@gmail.com. Hello. Hello.
Hello.
I'm just kind of like 44-7. You're rubbing it in my face, Noah. What on earth? Hi, Trinity. My football team for my college is so bad. They're so bad. Oh, they scored a touchdown, though. I mean, come on. That's awesome. Hi, Roman. This is Roman. I don't know if you can see him, because on my screen, I can only see your faces right there. So it's like I'm petting all of your heads. But he's named after the Book of Romans. He's my boy. He's Roman the Doberman. Okay, so It's also going to be weird for me to know, like, you know, avoid awkward silences because everything on my end is just an awkward silence. Oh, Trinity, by the way, I can't hear anybody but me.
Oh boy.
If you have a question, you have to type it. It's an emotion to me to stop talking and to look at the thing. Cool. All right, so to catch you up on what we're doing, we had about 45 minutes of technical issues. And so we have talked about, sad, we've talked about one problem, and it was number 72 on page 55. Cool. And all we talked about was that for an absolute value, you can express plus or minus as the absolute value instead. And so when you're trying to find a range of values that are acceptable, like for number 72, it asks you to write mathematically how volleyballs can be between 260 to 280 grams. So we found out the middle of that is 270. So then the acceptable range is plus or minus 10, which is the absolute value. We picked some variable x, and we said, okay, well, x has to be within 10 of 270. And if we're finding the difference, sorry, I got to update. Woohoo. Okay, if we're finding the difference between the weight of the actual volleyball and the weight of the volleyball, the ideal weight of the volleyball, that's subtraction. So x minus 270 or 270 minus x, just to find the difference between those. The absolute value of that has to be less than or equal to 10. Because it has to be within 10. That makes sense?
Mm-hmm.
Yeah, I bet you, Trevor and Noah, are like, why didn't she spend 2 minutes to explain that to us instead of the 15 that I actually did? Okay, so right now, everybody, I just would like to flip through chapter 1, have you guys just like pick up your books, flip through there, see if there's any concepts that you guys don't understand, you want me to talk about a little bit before we move into chapter 2. And when everybody has sufficiently flipped through chapter 1, give me a thumbs up.
Can you see that? I don't understand it.
625 minus x is greater than or equal to
25.
It just says 2. And it will zoom out the paper. 25. 25. 25. 25.
And that's for the basketball. For the basketball.
Basketball.
Is that right?
Oh, you want me to check it?
Yeah.
Huh! Okay. Basketball. 625 minus x. The absolute value of that must be less than or equal to 25. You did it! You did it right! Yay!
Okay.
Woohoo! Okay. I'm really proud that you could do that because that would cause a lot of problems for a lot of people. Yay!
Okay. So chapter 2. Whatever, you can't hear me.
So let's make a deal. I'll cheer for you if you cheer for UNLV. Oh, bad.
I wonder if my team's
Man, although it's kind of exciting because this is like the only way they would ever be on television. So, yeah. Noah thinks that's funny.
That's
Cool. Their basketball team is pretty good. Getting the Sweet 16 every year. I sat in accounting next to one of the basketball players. Okay, so Noah gets all of chapter 1. That's what the thumbs up meant?
Oh, that was actually for the basketball team, but sure.
Good.
Yeah.
Okay, so just waiting on. I mean, I see that your mouth is moving. Good.
Yeah.
I don't know what it's. I don't know the words that are.
Everyone else can hear me besides you. So obviously you still can't hear me. So no, never mind.
Can you guys hear each other at all?
Yeah.
You can? I'm the only one that can't hear you guys.
We all hear each other.
Why? I don't know how to fix it. I don't even know why it started happening. Everything was fine before. No, it's not that. I have your volumes turned all the way up. I don't. I don't know what's happening. I am presenting to everyone. I don't know what that means. It just says it on my screen.
Can you hear us? Oh, okay.
Can you see my screen?
Yeah.
So you can see yourselves.
I mean, we always could. Yeah.
You can see yourselves?
Mhm.
Can you see what I see? Yeah?
What does that
Okay.
mean?
So you can see me like scrolling my mouse and stuff? No.
No.
Okay.
No.
Hide their audio and video from my broadcast. What if I hit yes and then no? Okay, I hit yes. Everybody say something and see if you can hear each other.
Hello.
Hi.
Can you hear each other still?
Yeah.
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 This computer is 2 weeks old. What on earth? Okay. So everybody's good with chapter 1 then. Good. Okay. Chapter 2. I'm out of donuts.
I want donut.
I told my boss yesterday at work about the donuts from Thursday, and she was like, that sounds amazing. Go get some donuts. And that's how I have more donuts. I'm just explaining so that you guys don't think that donuts are like a staple of my diet. That's not setting a very good example for you youngsters. Okay. So I talked heavily in class about the independent variable and about how to tell if something is a function.
Mm-hmm.
You guys are good? Okay. And I talked about linear functions and how to tell. Can you tell by looking at an equation if it's a linear function? My sister just woke up and texted me.
What's a linear?
That's the noise.
I forget what a linear function. Wait. Linear.
You guys speaking?
Yes, we're all talking to each other. No.
No. Does everybody know how to tell yes or no if a function is linear by, okay. So if it's linear, there's a y or an x or both, but there are no exponents.
Oh, okay.
That will give it a constant rate of change.
Okay.
That make sense?
Yeah.
Cool. All right. So, range and domain, or domain and range. Does anybody remember what those are? Give me a thumbs down if you want me to say what domain and range are. Thumbs down. Thumbs down. Okay. So, domain and range describe values, like a set of values. The domain describes the values that you can do the math on, so what x can be. The range describes the values that you can get as an answer out of that, so the y values. For linear functions, the domain and the range are always all real numbers. The only time that's not true is if you have a linear function that's only one variable equals number, like x equals 4. X can't be anything but 4. So the domain for that is 4. But if you have any other type of equation, linear-wise, so there's a y and an x, or there's just a y, the domain is all real numbers. If you have an equation that says like y equals 5, well, the range describes y values because that's the values you can get as an answer. So if your equation is y equals 5, the range is, anybody? Hold up your fingers.
Say it again.
Okay, it's 5. If the equation's y equals 5, the range is 5. Okay, hold up your fingers. What's the range? Wait, you did this?
Yeah, could you repeat the question? Okay, whatever. 5. 5. This is terrible.
I don't know what you're communicating. It could be a 5. It could be a high 5. It could be a hello.
No, it's just a 5.
I can't see Trevor anymore either. I think after I hang up this phone call, I'm just gonna cry. Okay. So, we talked about function notations. That's 2, 1. Okay.
No.
Oh, is Trinity talking to her mom? Okay. So, when you are given a function, this is important. This is going to be on your homework. If you want to tell what the range and the domain are, it depends on how the function is given to you. So you remember I said that there are different ways to represent a function. You can show it as the function rule, which is like the equation itself, like 2x minus 5, y equals 2x minus 5. You can have the graph, which is a picture of it. You could have a description of it, which I said was dumb, and we won't be using very often. Or you can have like an actual Nice, Noah. I still can see it. Okay. Or you can have a list of the values that the x is and that the y is. So if you're trying to find the domain and the range, depending on which form the function is in, you would adapt the way that you report the domain and the range. So if you are given a graph or you are given a function, like the actual equation itself, unless the graph indicates that the line stops at some place or they're only individual points, then the domain and the range are both just all real numbers. Trevor's iPad battery just ran out, so now he's plugging it in and rebooting. Okay. So, here, these are not lines. These are just points. So the domain and the range are just going to be the x and y values for these points. And that's it. You just list them off. Cool? Cool.
Okay.
Here, this is not a function because there's more than one y for x's. To tell something is a function, you just see if you can draw a vertical line through it. If it touches the graph more than once, it's not a function. Good, good? Okay. So that's all of 2-1. Okay. 2-2. So 2-2 is still review. If it doesn't even feel like review, I mean, that's okay. It doesn't start becoming not review until 2-7. This is all in our homework, right? Yes. I'm guessing that Noah was just asking himself, do I have to listen to all of this? I'm just kidding. Yes, all in the homework. Okay. So, but your homework for... I have to give you more homework today. But then you will be totally caught up to the Aliso Viejo class. And that's the end of the extra homework. Yay! Okay. So, we're talking about 2-1 and 2-2. We just finished 2-2. 2-1. So, we're talking about slopes now. So, if a function graphs as a line, it's going to have a constant rate of change. It's just the only, the highest way that y can change compared to the x is just through multiplication. Not exponentiation is when you raise something to an exponent. That's an actual separate operation. So when we talk about the order of operations, the operations are actually all 6 of those, and then there are more on top of that that you will learn later in math. But I remember the first day Trinity was like, "There's more!" And I thought that was very funny. So, yeah! There's so many more! Did I tell you the thing about the algebra degree? How long it takes to get your doctorate in algebra? Yeah? Do you remember? 2? 5. I can't tell what Noah is holding up fingers-wise. 4. Nope. So, it takes 10 years. Yes. So that's 10 years after you have actually gotten your college degrees. That's when you're just working on getting your doctorate. So, say you graduate from high school 18 and you're just like, oh my gosh, math is the best. I want to study this forever. You go to college for math. You graduate at 22. You're like, man, I really want to know more about math. So you get your master's degree, you graduate at 25, and then you start your doctoral program. So, if you never take a break from school, when you are 35 years old, you will have learned all the known algebra. You've only been doing it for like 2 years. There's so much. So much. Okay. So, slope and rate of change. I know that a lot of class seems like me sadistically laughing at you. I feel bad about that. But I hope this is encouraging in some way. Okay, the Berrioses are back. Yay!
Going back to the kitchen.
Oh, a dog!
There's Trevor on the floor. Cool.
Can you hear me?
44-7. Yeah, we have the ball! We have the ball! We're gonna do stuff with the ball!
Right.
We're gonna lose it really quickly, and it's gonna go back to Ohio State. Okay. I used to go to those games. Do you know what it was like being there in person and watching that? Wow. Okay. So,
Can it do something?
line.
Mom, you want to do it? Do you want to do it? Mom.
So,
Is anybody here on
by
this side?
definition, it is a line
Can anybody hear?
because
Yeah.
every
Yeah,
time
I
that you
can
move
hear-
from
I
one
can
point
hear
to
you.
another, the x has changed and the y has changed the same way as it has from this point to this point. Even if we're choosing points that are farther away from each other, they're only because the only thing influencing the change in the y from the x is multiplication, then you can just divide it back down to the exact same reduced ratio of the relationship between the y and the x. So, like, say we have the point 2, 6, and 4, 8.
I can't see. We can't. Up there. Yeah, that's
Oh,
better. Yeah.
Okay. Then, to find the slope, we need to find what the actual relationship is in between the x and the y. We need to find the actual ratio that expresses how much the y changed compared to how much the x changed. And it's very important that the y is on the top and the x is on the bottom. Not because x is less important. That's not why x is not on the top. X is way more important. Like if we're talking about eating a box of cookies, and I tell you that you can have a fraction of the box, it makes a lot more difference if I tell you how big the bottom number is than how big the top number is. So if I say you can have 1/2 of the box, that's significantly more than 1/5. Right? So the bottom number is how we define what the terms are for our given ratio. That makes sense? Yeah. Cool. So here, to find the actual change in y over the change in x, this is a triangle, but it's the lowercase Greek number delta, or uppercase, excuse me. So delta y over delta x is how in calculus we refer to the change in y over the change in x. But if we were going to write this formulaically, how to find that change, we would write y2 minus y1 over x2 minus x1. This should be familiar. You should have seen this in Algebra 1. You're going to use it a lot in this chapter. Okay? Everybody comfortable with how to find slope?
Mm-hmm.
Trevor's nodding. The other two are motionless. Oh, Trinity's good. Noah's.
Kind of.
And okay.
Okay, come
So,
here.
if we have this point, for example, or these 2 points that are on a line, we need to find how much the y's have changed, and then we need to compare it to how much the x's have changed. So, how much has y changed, moving from 6 to 8? 8 minus 6.
Okay.
2. Right, so if this is our x1, and this is our y1, and this is our x2, and this is our y2, we're using little 2's to indicate that's y of the second point, of point 2. That doesn't indicate math. It just refers to which y we're talking about. There's clearly more than one y. So 8 minus 6 is y2 minus y1 over, and then we have our x's. So how much have the x's changed? So we need to figure that out by doing 4 minus 2, because the x's went from point 2 to point 4. Right, 2. So 4 minus 2, 2 over 2, which simplifies to just 1. So our slope is 1.
Okay. Okay.
So even if we pick different points, like say we want to measure how much it changed from 0.48 to point
Jade.
36, 42. We would 42 minus 8. Hang on, I'm not doing my math correctly. 40.40. 40 minus 8, because that's the change in our y's, over the change in our x's. 36 minus 4.
Okay.
40 minus 8 is 32. 36 minus 4 is 32. Still comes out to be 1. Good? Okay.
Yeah.
So, because slopes tell us the rate of change for our x's and our y's, and our function is defining the relationship between the x and the y's, slope is the most important thing that we can find about a line to describe its characteristics. It's what tells us the most information about a line. So if we're comparing one line to another, what do you think we need to know about those lines? What actual characteristic do we need to know and compare?
Jade, be quiet.
Oh, it's your dog. Oh,
Yeah.
I thought it was Trevor's.
Anybody have any
Sorry,
guesses?
there's a dog barking. I couldn't hear. Sorry.
I don't even know if I'm talking over you. I have no idea. Can't hear anything.
No.
Just me. So,
Kind of. Whatever.
sorry my dogs were barking. Pfft. Okay. That's okay, Trinity. Couldn't hear it. Okay. I had no idea. My dog barked. I don't know if you heard that. My Roman's over there. He follows me everywhere. He's my best friend. Okay. So, what is the most important characteristic about a line?
The
Mouth read. No, are you talking? No. Okay.
I'm thinking.
So,
I'm thinking. I don't want to think.
okay.
The most.
So, slope is the most important characteristic of a line. So everyone will say, oh, she just said that. There you go. Cool. Okay. So, what characteristic do you think we use to compare one line to another?
Slope. So, slopes. Slopes. Do we have to type it?
Okay, everybody mouth your guess.
Slope.
Slope! Yes! Yes!
Yeah.
Okay. So, if we have two lines, and we're comparing them to each other, that's not right on that page because I'm using marker and it bleeds through. Switch to blue. Like in Sleeping Beauty. Has everybody seen Sleeping Beauty? Make it pink. Make it blue. Okay. So
They're stuck on here.
we have 2 lines. Is Trinity looking back because her dogs are barking again? Okay. Are they done?
I don't.
I mean, I don't care if they bark. That's awesome. But I just want to make sure you can hear me because I have no idea what you're hearing. Okay. So, parallel lines. So if lines are parallel, that means what about their slopes? Okay, I'll just go ahead and tell you. So,
Oh, they have the same slope. They
it looks like Noah just realized something.
have the same slope.
Now it looks like he's just waiting for me to talk. Yes?
No, I typed it. Look in the chat.
I wish I could hear you. They have the same slope! You
Look in
typed
the
it!
chat.
Yes, they do! Okay, they have the same slope. Yes! Because if they're parallel, that means they won't intersect. So it's like having a little brother that follows you everywhere you go. Every time you take a step, he takes a step. He doesn't ever get closer to you, and he doesn't ever get farther. He's annoying. That's how parallel lines are. Because the rate of change is exactly the same, and so they never intersect. Because every time this line has changed 2x and 2y, this one did too. Okay.
Yeah.
So if we're testing to see if lines are parallel, we just want to see if they have the same slope. Are these lines parallel? Trevor says yes. Where's the slope? Y equals mx plus b. Which one of those letters is the slope?
2/3. 2/3.
2/3. Yes. Is that what you said?
Yeah.
Okay.
Yeah. Yeah.
Yes. Slope. Those are the only numbers we're looking at if we're trying to determine if the lines are parallel. 2/3. So if we have lines that look like this, to compare if they're parallel, we need to find the slope first. You can't tell from looking at this. These are both in standard form. Standard form is stupid. Cool. So,
Okay.
first thing that we need to do is to get the y by itself. Because when we can actually see our slope, the equation is in y equals mx plus b form. So, start with this one. I made the sound effect. So 10y. Are you asking a question? Or? Okay. 10y equals, subtracting 5x from both sides, negative 5x plus 7. And then divide by 10. It's Trinity yawning too. Okay. Y equals negative 1/2 x because 5 is 1/2 of 10 plus 7 over 10 plus this number I don't care about. When I'm going to compare that they're parallel, I'm only looking at this. So 3x plus 6y equals 7/2. So subtract 3x both sides. 6y equals 3x, negative 3x, because we subtracted it, plus 7/2. Are you yawning again? Okay, divide everything by 6. And you get that y equals negative 1/2 x. And then you actually get plus 7/8 or 7/12. This number, that one, meaningless if we're only comparing if they're parallel. Are these numbers the same?
Can't tell.
Negative 1/2 and negative 1/2? Good. Yes, they're the same. Are the lines parallel? Trevor's just doing this. Yes, are they the same? Yes. Good. I'm guessing that Trevor's facial expressions just aren't as expressive as mine. And so I should, like, adjust how I'm interpreting them. Okay. So, I was just thinking about the odds earlier. Okay. So, if lines... We scored again! We got 10 points? No, 7, because I'm a math teacher, so I should have 14 minus 7. I can't believe we scored! I'm missing it! This is incredible! I'm surprised my husband hasn't come, like, running in here. They scored! Because he asked me if I would be happy if they scored a goal. It's like the outcome. Oh, hi, buddy. Yes, I would. Hi. You want to learn math? You don't know what that is.
Oh, he's so cute.
So, if lines are perpendicular, so a way to think about it. I love him. If lines are perpendicular, that means that they're exactly as opposite as they can possibly be. Now this number, or this line, and this line, like the sections of it, they're far away from each other. But if we make them any farther away from each other, like to go from here to here, we extend this angle, we've, by just the definition of a line, made this angle smaller. So they got closer to each other here. So the way to make the lines as absolute opposite of each other as possible is to have one be up and one be down. We can turn it any way we want to, but really what we're talking about when we say as opposite as possible is that they intersect at a right angle. Does that make sense? Okay, so if lines that never intersect have the exact same slope, can you guess lines that intersect at exactly opposite what their slopes are like? Opposite! I read your lips! Yeah, they're opposite! So, but something else to consider when we're talking about opposite, what's that mean? How are they opposite? Well, one has to be moving this way, and the other one has to be moving this way. So one has to be negative and one has to be positive. We know that. But then how do we talk about opposite if we're talking about change? Change in y over change in x. Well, the opposite of y is x, and the opposite of x is y. So if we have our first slope changes negative a between the y's and b between the x's, then our second slope changes b for the x's and a for the other way around. A, b for the y's, a for the x's. Does that make sense? Would it have made sense if I actually like used the appropriate words instead of messing up? I hope so. Okay. So if you're testing to see if lines are perpendicular, all you need to do is compare their slopes. If they are opposites, like these two are, if I multiply them together, a negative, remember only one can be negative because they have to be opposite. A negative times a positive is a negative. And then those should cancel out everything. So you're just left with -1. So if lines are perpendicular, their slopes are referred to as negative reciprocals, and they will multiply to -1. So if you have equations, like these two, you find the slope, and then you multiply them together. Hopefully, you'll get very familiar with this, and so you'll be able to just recognize without setting up the multiplication that they multiply together to be -1. They have the same slope and going. I'm going to get some water. Okay. All right. So, wait. What if I go get some coffee when he does that? Is everybody okay with that? Yeah. Cool. Okay.
Krista, come here.
Because it's almost empty. So, I'll be right back. Cool.
Callista, come here. Come here. Come here.
How old is your dog?
She's 10, I think. We've had her for a while, since I was a kid.
Wow.
Yeah. Hi.
Trevor, can you can you unmute?
Hey guys!
Right. So can you unmute? Cause I accidentally muted you.
Copy. Oh, hang on. I was thinking about the yawning again. Excuse me. Hey! Cool. Oh, puppies! Puppies!
Mine. Wait. Okay.
This is Roman, if you're wondering. Okay. So, I think that's it. Noah's gone. He's getting his dog. Everybody's got dogs! That's a person. Puppy! Oh! Oh!
Oh, puppy.
Yeah, I have to do my right. I have to do that. Right.
Yes,
Okay.
I do.
No, he's up. I don't want to.
Oh, Anna's here too. Anna, look.
Good.
Anna,
Good boy.
Come here. Yes. Can you see both of them? Oh,
Oh!
my babies!
Really?
These are my babies.
I'm gonna go bark at
I
them.
love them so much. Anna's yawning too.
No.
Alright.
Romy.
You here now?
They love each other.
Yeah.
I love them
Yeah.
and they love me. Lots of love. My babies. Okay, so the only other thing that's going to be in your homework is how to turn problems into equations. And so, sorry, I stayed up way too late watching King Arthur, which was not even that great. So, but I wanted to see it because Guy Ritchie directed it, and he directed the Sherlock Holmes stuff. And I like those. Yeah. And the Astros are killing the Angels too. So all my favorite teams are currently losing. It's great. It's good. It's good. Okay. That's okay. I'm victorious. Because God won. Okay. I have to cling to that. Well, I mean, for all things in life, really. Just might get awkward. Okay. So on page 78. Nobody wants to flip there. I'm so sorry. Excuse me. On page 78, there's example 6, and we can do that. Everybody give me a thumbs up when you're on page 78. Oh, and Trinity, thank you so much for saying our dogs are cute. I love them. I picture
Right
everywhere in this room. I don't even know.
It's 78. Good. We're good.
Everybody's good. Okay. So, in the Mojave Desert in California, temperatures can drop quickly from day to night. Suppose the temperature drops from 100 degrees Fahrenheit at 2 to 68 degrees Fahrenheit at 5. Find the average rate of change and use it to determine the temperature at 10. So, I hope... Oh, Trevor's gone?
No.
Oh, there he is. Okay.
Oh, just
So, I hope that I have used slope and rate of change interchangeably enough for you guys to realize that those are the same thing. Yes? Okay. So, if it's asking for the rate of change, it's the same thing as finding the slope. So all we're going to do is find how much one variable has changed and put it over how much the other variable has changed. The question just becomes which one to put then on top, right? Lost my cat.
Okay.
Okay. So typically time is going to be the x because time is very independent of anything that we can change. It just happens. The only thing that really exists outside of time is God. Except, did you know that time really isn't an unchangeable factor? The faster you're moving, the faster time moves. That's the theory of relativity from Einstein. That's what it says. And so this is true. They actually put the world's most accurate clock that uses like these super accurate crystals to determine time. And they put it in a jet, and they flew around the world with it. And by the time they got back to the exact same spot, it was milliseconds ahead of what the time was in that spot. Does that make sense? Because it moved faster than the spot. Okay. Plane. Plane. Flew around the world, and when it got back here, the time in the plane said that less time had passed than the world actually had indicated. Does that make sense? Noah, you look confused.
No,
Got it?
It's fine. It's fine. Yeah, sure. I'll figure it out. Proceed.
Just such dead silence over here.
Proceed. Go. Math.
Okay. So
Math.
that means
Do
it
math.
took,
No, do the math.
because the plane was moving faster than the Earth was, time moved faster for the people inside the plane. So by the time they got back to the exact same spot, time had actually moved faster than the people that were just remaining in the spot, because the plane had been in motion and been traveling faster than the people that just stayed there. So time is relative to speed. That's what E equals MC squared means. Isn't that cool? So later when your parents are like, what'd you learn? I learned Einstein's theory of relativity. And has anybody seen Interstellar, that movie? So as they get closer to a black hole, they talk about how time on Earth is going to be like 10 years for every hour that they're on that planet. That's because the black hole, they're orbiting a black hole, they're moving so much faster than the people on Earth are through space that the time is going like 240 times as fast as it passes on Earth. So for every 1 hour that they were on that planet, it was like 10 years back on Earth. Isn't that cool?
So did they grow that old?
I'm guessing that Noah's asking if this is going to be on the homework. That seems to be pretty characteristic of Noah. So, no, it's not. I'm not going to give you Einstein's physics problems on your homework. But one last fact about black holes, since I can't hear anyone, so you can't oppose me. So there are two different schools of physics. There's quantum physics and classical physics. Quantum physics have to do with like particles and studying how that all works, and classical physics has more to do with like forces and stuff. So both of them have theories and laws and explanations to what will happen as you approach a black hole. So there is this thing around a black hole called the event horizon, because the black hole has so much gravity pulling things towards it. There's a certain point, like a line around the black hole, where anything within that line gets sucked in, because it can't withstand the force. Everything, including light. Light cannot escape from a black hole because it sucks in everything. There's so much gravity. So you have to be beyond that like border in order to not get sucked in. So we have no way of knowing what happens beyond an event horizon. That's what it's called. Because as soon as you get past that, you can't escape to send back data or to do anything, say what's happening within that. It's all just theory. So classical physics and quantum physics. Classical physics says that as you pass the event horizon, once you get in there, it's just that your like system has changed about like how gravity is and what kind of matter there is and everything. So you will just continue to fall towards the center forever, just like rotating. But you will be in like complete equilibrium. You won't experience anything. And then quantum physics says that things only happen if you can observe them. So if you can't see what happens beyond the event horizon, then it didn't really happen. So it says like passing through the event horizon is the same thing as passing into nothingness, into just being obliterated instantly. But it also says that because you can't see it, there's no way to measure like what it is, what happened. So both of them say that you can, if you combine them, they both say when you pass the event horizon, you can blow up instantly and you can exist forever at the same time. Is that cool?
I'm gonna try.
And because quantum physics says that it doesn't really happen unless you can observe it, those can both, scientifically and mathematically, happen at the same time. They can both be happening. You can exist forever in an equilibrium state, and you can be blown up instantly. Cool. It's okay if you don't understand it, because that's like one of the massive mysteries of science right now. Okay, 14:54. We have points on the board. I think that's beyond what anybody was expecting. When I looked at the ESPN calculator today about like who was supposed to win, they gave UNLV a 0.5% chance of winning. So we scored! I mean, come on! And we did it twice. I'm pretty happy about it. That's like a victory to me. Cool.
Percentage.
99.9. Okay, so the percentage went up. Okay. Okay. So, I think that actually concludes math class. Because I think we went through everything. What do you guys think? Aren't you super happy that I made you listen to all that stuff about physics and black holes before I actually told you that we were done? Okay, so unless anybody has any questions, because if you have any questions, then I will go over that. Puppy! What's your puppy's name?
Jet. Jet. J-E-T.
I'm not picking it up. Jet. Ah! That's clever. Jet. I like that. I want to have a son and name him Axel.
I'm gonna steal your dog.
It's a family name because I'm descended from the Vikings. Really, I am. He's sleeping. Oh, sleepy puppy. I love Puppy so much. I love him too. Puppy! Okay, so if no one has any homework or questions, of course you have homework, and I'm giving you more now. Alexander the Great bust fell off. Okay. This is awesome how quickly we moved. And so now we're like caught up to the Aliso Viejo class. Okay, so your homework is... Did I already give you homework from page 53? I think I didn't. Give the homework to my dog, LOL. Okay. No, there is homework from page 53 already? Yes. Okay, is it 17 through 105, every other odd?
Oh, yeah. Wait,
Yep.
I have it here.
Did I give you homework from page 58? I think I didn't. I think that's where I said I stopped.
No, you did. You should look.
Oh, I did. Okay. Oh, that's my handwriting. Okay. So then, thank you, Noah. Your homework for tonight / any day, because the whole thing's just going to be due on Thursday, is that one. So
Okay.
page 71, 19 through 53 odd.
Can you text it to me?
Oh, you know what? I could just type it. Then you guys can see it, right? So, page 71. 19 through 53 odd. Yes, no, I'll text it to you. 19 through 53 odd, and then page 79. 17 through 53 odd. Everybody get it? Good? Yep. No, do you still want me to text it to you? Or did you get it from there?
No, I'm good. I'm good.
You're okay now? Okay.
Yeah.
And Trevor, did you get it too? Did you nod? I can't tell. Did you get it? No?
No.
Oh, it's in the chat. It's in the chat. Trevor,
What is on
go
page
into
71? Okay. 19 through 53 odd.
the chat.
Okay.
So, like, if you, there's a blue
And then,
chat
do you still
button,
need page 79?
and then click on it.
Can you see the chat messages, Trevor?
Yeah.
Here, I'm just going to click on back over
Just texted something
to,
on the chat.
so, page 71, 19 through 53 odd.
Yeah.
And then what else is it?
What's wrong?
Page
Okay.
Okay.
19 through 53 odd. Okay. Is that everything for the homework? Everybody's good?
Okay.
Okay. So, that concludes math class. So then, if Noah wants to ask any questions about world history, then that's should be it. Okay.
Okay.
Well, good luck, you guys, and we're done. So if you want to hang up, that's an appropriate time. And let me know if you have any questions. I'm sorry we had so many technical difficulties getting started. In the future, I'm going to figure stuff out. I've never been so technological before, and so I have no idea why my computer wasn't working today. I specifically bought a new computer to avoid those problems. So I don't know, but I'll figure it out. And okay, so bye, Trinity and Trevor. But Noah, do you have questions?
Yeah, I'll stay.
Okay, so if Trevor and Trinity want to hang up and just text me if you have any questions about the homework, and then I'll just stay on with Noah and we'll talk about world history. Bye.
Can you hear me now?
So here's Noah. Can you
hear me?
I still can't hear you. Okay, so I'm going to call you right back from the actual, okay.